Hey everybody, in this video I want to go over the different types of delta H's that you might encounter, and these are the most common ones, and by no means do these cover everything because there are countless types of delta H's, but these are just the most common ones. So let's begin. The first type of delta H you might encounter is when things are undergoing a physical change, such as fusion, vaporization, sublimation, and etc. And these types of enthalpies involve the change in enthalpy for 1 mole of matter undergoing a physical change. So for example, the delta H of fusion is when 1 mole of solid is converted to 1 mole of liquid via melting or fusion, and the delta H will correspond to that. Now, there's a very special type of delta H called the delta H of mixing. This is the change in enthalpy in mixing to create 1 mole of products. So in this example, I mixed H2 and O2 to create a mole overall of an H2 and O2 solution, and I call it a solution because this is mixing two things that are basically invisible to the eye, so you can't really separate them, and in the end you have a homogeneous solution. So the next thing I want to talk about is the delta H of solution. This is the change in enthalpy for dissolving a mole of solute into solution, which is typically water, the universal solvent. So in this example, 1 mole of substance A is dissolved into water to create 1 mole of aqueous substance. So that's all. And the delta H of hydration is a change in enthalpy for hydrating 1 mole of a substance in the gaseous form. In this example, 1 mole of A is converted from a gas into its aqueous form, and the delta H will correspond to that. Now, we have two types of delta H's that are very similar: the delta H of ionization and the delta H of quote-unquote electron gain. The delta H of ionization, and this is directly related to ionization energy, is the change in enthalpy when you remove an electron from 1 mole of gaseous matter. So in this example, this becomes this, and 1 mole of electrons is removed. Now, the delta H of electron gain is when you add an electron to a mole of matter in the gaseous phase. So in this example, 1 mole of A plus 1 mole of electrons becomes 1 mole of A minus in the gaseous form. Now let's move on to other enthalpies. The delta H of reaction is just the change in enthalpy for a mole of reaction. And keep a note that the coefficients in the reactions don't typically have to be equal to 1. So now that we're done with that, let's talk about the delta H of combustion. This is the change in enthalpy when 1 mole of substance is combusted. So the reaction corresponding to it is in red. It's showing methane, 1 mole of methane, combusting to form, the products, and that will correspond to the delta H of combustion. Now the delta H of formation is a change in enthalpy when 1 mole of substance is formed from the elements in their natural common form. So in this example, carbon and O2 gas, which is naturally found in nature, combines in a stoichiometric ratio to form CO gas, and notice it's 1 mole of it. Now let's move on to 2 more types. Bond enthalpy is a change in enthalpy when 1 mole of bonds is broken in the gaseous state. So in this example, 1 mole of CO single bonds in the gaseous state are broken down to form 1 mole of C and 1 mole of O, both in the gaseous state. So that's delta H of subscript Be. Now what's delta H of lat? Well, lat stands for lattice, and this is specifically the lattice energy of formation. It is the change in enthalpy when 1 mole of salt is formed from the gaseous form of the ions. So let's do some thinking. Will the delta H of lattice be positive or negative? So in order to do this question, we have to look at the reaction, and the reaction shows 2 ions, Na plus and Cl minus, both in the gaseous form, forming an ionic bond to form sodium chloride solid, which is what we use in table salt. So since a bond is being formed, that means that it's releasing energy, right? So if it's releasing energy, just like how when we form bonds in bond enthalpies, we make the delta H's negative, then the delta H of the lattice energy is going to be, well, it's going to be negative because we are forming bonds, and forming bonds releases energy. So the delta H of lattice, the process is exothermic. Alright, so now that we're equipped with this knowledge and with ways to figure out whether things are exothermic or endothermic, and note that this doesn't always work, but in this case it did. So that's all for this video, and have a wonderful day.